the theme of this talk is around agents, and where I think the fundamental flaw will be around agents. That's not to say they're not valuable. That's not to say a large foundational model isn't valuable. They're fantastic, I promise. But there is a fundamental flaw that I think a lot of folks are missing here. And unless we, effectively shift our thinking left to our entire pipeline, I think we're going to get in trouble. So I like to always start a talk with a controversial statement. We're building smarter and smarter agents on top of dumber and dumber data. And, I hope I make a compelling case here around this, but this really is kind of the theme. If you walk away from nothing more than this, almost everyone in this current AI boom is focusing on the things before the ellipsis. How do I make it smarter? How do I connect it to my endpoints? How do I make it act on my behalf, and so on? And very, very few people are thinking about, was this trained on the right data? Is the data the right shape? Is it the right data, but too much, right? Too much data is just as bad as too little data. Models are very bad around context and things like that. And not just in the training realm, in the inference realm as well. As an aside, I always think it's really funny. I've been in this game for so long, and it must have taken me at least 5 years to remember what training versus inference was. I don't know why. We choose the worst terms for this stuff. It's like build models, use models. Anyhow, a little aside for you there. But it is that bottom part. Unless you are really thinking about how you're training the data, how you're building your models, agents on top of the data, but then also how you're feeding your agents with the right size and shape of your data, you're going to have a bad time. This will not come as news to anyone on this call. The world of data is exploding. We know that, and truly AI cannot keep up. We built these massive lakes, but the truth is they are for intelligence and sorting and filtering, and in a lot of ways, I don't mean this rudely, but the old style of doing things. You would throw things into an OLAP or an OLTP cube, or take your pick, and you'd build a bunch of views and you'd go off to the races. Especially with the size and shape and quality of data that we have today, that's just not going to last. I mean, I didn't even know how you build an OLTP cube over video, right? I mean, I know you probably can, and lots of people on the call are like, I've actually done that. But I'm telling you, it's certainly not the most optimal way to do what you need to do. And if you look at Gartner or IDC, the numbers are truly eye-watering. What I like to say is, the idea of centralizing everything barely worked even in the era of big data. You could argue that Google was built over the entire idea of centralize everything. They scraped the entire world, and they invented MapReduce. I mean, not MapReduce, the concept, but Hadoop, their internal MapReduce, which ended up becoming Hadoop. And that was the way to process in a distributed way all the data that the world had to offer. It took a company with the skill and dedication and so on of Google to invent this thing and actually make it work. Just about everyone else had some horrific story about how they stored stuff and it never did anything, and they lost the lineage, and they didn't know what the schema was, and oh my God, the pipelines broke, and so on and so forth. And now, of course, it gets even worse when you start thinking about that. But for AI, my God, you're insane. People are out there. I mean, even this past week, people are talking about how they're using whatever H200s for training or for inference, and you're like, what are you doing? You could not possibly be wasting more money. It's not because they're not excellent chips or excellent things, but they're entire systems designed to do full, cross-sectional, ring reduce and other highly complex AI models and training, not for your inference. And yet we throw these things at it. And again, it just gets worse in the world of big data. So I like to say, if you do nothing else but leave this talk and go back and look and say hey, are we intelligently centralizing everything? Because that feels like the easy thing, right? Everything's got whatever, HTTP or FTP or whatever, and we can push it around. But is that smart? To move a petabyte around, just for the sake of argument, at 10 gigabits, which is the highest bandwidth that AWS offers, inter region, it would take a week and a half to move a petabyte, right? Like, it's just so much time. You simply cannot move at that speed. And there are plenty of people who are not moving that much volume, but their network connectivity is at risk, right? 10 gigabits is super fast, but imagine you're moving things from your on-prem data center to your cloud, or moving things from your retail location or your factory location or your self-driving car. Now you don't get 10 gigabits. You get one if you're lucky. And more often than not, you get like a 3G or 4G connection. So it gets even worse, and the ability to move the data gets even harder. And we haven't even gotten to the other areas, right? One, speed of light isn't getting any faster. That means that if your model is in one place, or your data is in one place, and you're shifting everything across the country, congratulations, you just ate 80 milliseconds of latency. And that will be the same 80 milliseconds of latency in 10,000 years, because the speed of light's not going to get any faster. So you're already adding latency, but you're also adding these other things: security, compliance. The moment you touch the data, the moment you move it, you're going to start running into challenges. And again, it's not to say you shouldn't centralize things; it's you shouldn't centralize everything. That is the key. And again, if you leave here and go back and look just at what you're doing in order to figure out what the right motion is and how to be a little bit more selective, then you'll have a big win. This is the modern data stack. I want to be really clear. Everything on the right-hand side here is exceptional. And there are many, many others. I couldn't even capture them all in these slides. We live truly in a cornucopia of excellent tools. But what I say here on the slide is the truth. They all assume that you've moved all your stuff into a central warehouse. Now, does that mean I need to build a highly complicated distributed query system that crawls over every machine and acts like a centralized database even when all the machines are 1,000 kilometers apart? No, of course not. But it means you are thoughtful. How does the data get there? How do I manage remote policy? Who cleans up the mess before I move it? Because if you're just moving the raw stuff, that's not the right thing. Again, it doesn't mean you don't do the stuff on the right. The stuff on the right is great. But it is mean you be thoughtful about it, because the physical world is the physical world. And those things on the left-hand side are going to be there forever. There's no world, no matter how great Amazon and Google and Oracle and Microsoft and so on get, where the entire world sits inside a data center in Iowa. It's not going to happen. So I don't know, maybe 10,000 years when we're all virtual machines. So everything on the left-hand side, is going to be there. Arguably, even when we're at 8, when we've all uploaded our brains to the cloud, it's still going to be there, because we're going to be split out all over the place. And figuring out how to deal with it sooner rather than later will save you an enormous amount of pain. Now, here's the small commercial interruption where I talk about our platform is built to do this, but I really want to stress, even if you're like, hey, Dave, I don't trust you, I don't trust your platform, the things I'm saying here still matter. And they really involve, you figuring out how to do these things on your own, because you do need to run in multiple locations. You do need to run on unmanaged infrastructure. You do need to run on low resource devices, and you need to sit in front of your existing infrastructure, not in replacement to it. Again, I can't stress enough. The things on the right are exceptional. They're not going to be going away anytime soon. But it's more about how do you think about those things, and how do you shift your entire process left? Because when your pipeline, when your data is smaller and cleaner and more well-structured, everything becomes more efficient. It makes it faster, cheaper, and safer. I'm going to walk through 3 key use cases around what it looks like to shift left. These are real use cases that we have seen. And, again, whether or not you use our platform or someone else's, this is stuff I've seen repeated. And likely is going to be highly valuable for you in the future. The first is around the concept of a distributed data warehouse. What do I mean by this? I don't mean that, again, you have a general, highly, low latency distributed query where you figure out mapping and reducing and so on and so forth. But it means to be thoughtful about what you move into your data warehouse. It is completely logical to, for example, take some portion of the data you're generating from your temperature sensors or your transaction logs or your factory floors or your self-driving cars or whatever it might be, and say, hey, you know what? We're just going to average these things. We're not going to move it all into this backend. We're just going to do some initial analysis of it here, and then we're going to move the results of that analysis back. And those analysis can be very straightforward. We're going to clean it. We're going to remove noise. We're going to average. We're going to, do windowing, whatever it might be. Again, you're still using your backend centralized data warehouse, but you're being more thoughtful about it. And this, again, if you do that, you reduce costs, you improve your performance, and you reduce complexity. Again, because these are the things that hurt everyone. So what it looks like is something like this. Let's say, and I have a retail example here. Again, it applies to so many industries, healthcare and financial services, where these borders aren't physical, they're logical, because data in Spain can't be shared with data in Germany, can't be shared with data in the UK, because of local regulations and so on. You have these kind of borders all over the place. In this case, I'm talking about IoT, but it could be machines, could be whatever it is. The data that comes off of those places, out of those APIs, out of all that stuff, often is very poorly structured. Or maybe it's really well structured, but it's not structured in the way that you need. It might lose metadata and other things. And your job is to move that back, across unreliable connectivity to your backend data warehouse. And what that results in is too much data being stored and your data lake being overwhelmed. What we recommend is a pattern like this, where you set up what we call near compute. Now, this is compute you have on your own, you own it. In our case, you would put our agent on that, but again, you can write it yourself. You collect locally from that information, and you store it in a highly efficient local format, iceberg table, parquet, whatever it might be. And what this enables you to do is you have a strong, typed system locally that can still allow you to issue arbitrary queries against. But it also makes it much easier to be thoughtful, doing things like averaging and schemization and so on. And before you push back in your data warehouse, becomes much, much easier. You write to that table incrementally, and then you just pull off what you need in order to push back. You can still stream. You can still do data adjustment. You can still use the exact same ETL you were using earlier, except you start a little bit later in the pipeline. The next idea is around streaming data pipelines, right? Where, let's say you have a server which is producing an average amount of data, right? Your log exhaust, maybe a gigabyte a day. Not that big. But small deployments can add up as you start to add microservices, as you start to add many machines, you add local machines, all that kind of stuff. Your networks will always delay the flow, because you will be able to produce data far more quickly than you will be able to move it over a network. Again, this not to say all that stuff on the right, the SEIMs, the Databricks, the data warehouses, Snowflakes of the world aren't great. They are. But moving your raw log data in there is costly. It is slow. It is not what they are built for. Even when you talk about things like bronze tier and silver tier and gold, those are assuming you've done a little bit of the work. If you're moving raw log data into bronze, you're going to have a really bad time. What we recommend is instead you run on your local machines or nearby your local machines, and then still use the same SEIM you were using before. And so what this looks like is, today you might have these many servers, maybe they're all in a single location, but you are moving all that raw log data. You have a generic shipper, and the shipper just, grabs, the last stream and pushes the last 1,000 lines that it had on there. If nothing else, this increases your attack surface area. Log4j was specifically an attack on this, where you took raw system queries and pushed them into your backend, S3 buckets, and then began to process. Because once you cross this line of now inside your central warehouse, you're increasing the surface area of attack, because that Log4j processor is operating in that security context. People are like, well, it's just a log processor filter. How bad could it be? Well, I mean, it almost took down the internet. So, it ain't good. It also is moving too much. And by the way, as you move further and further to the right here, your costs increase enormously. The cost to store a piece of data on hot S3 is 100 times as much as it is to store on your local disk. And by the way, as you get it into a hot index table, it's probably 100 times on top of that, plus the cost to do generic CPU and other things like that. If you want to run your agents and you want to do it efficiently, the further left you can push your agents to process the data and think about the data and use the data, the better, faster, cheaper, more isolated you're going to be. So what we recommend is a pattern where you run processing your initial pipelines on or near your lockdown machines. And by doing that, you reduce the total amount of log ingestion you're moving. And that means you've simply, just by doing this, again, the rest of the pipeline remains the same. The reports look the same. The back end remains the same. But the amount of data you're processing has reduced significantly. And that just, again, even if you had unlimited money, it just makes everything run more efficiently because now your pipelines are operating over an appropriate amount of data instead of, completely raw log data. And by the way, it also gives you the opportunity to move things to archival storage much more cleanly. So now, instead of moving your raw, unsanitized log data into your central data warehouse, you're now moving it to archival storage. And then it can be treated as an isolated deployment that is also, by the way, much, much cheaper. But if you need audit logs, then you can, it's now storing it for 3 or 4 years is, now realistically possible instead of, saving it on a hot S3 bucket. And then we get to streamlined data pipelines, So like I said, you run the pre-processing in location. You're able to take immediate actions as well. I didn't even mention that. Like if you see, hey, this machine threw 6 500 errors in the past minute, I'm just going to automatically remove it, mark it unhealthy and remove it from the load balancer. If you had to wait until it gets to the end of your data pipeline to do that, you're similarly going to have a bad time. And you can see enormous cost savings here. Again, cost often isn't the problem, but this is a completely real world scenario that we mocked up for a particular customer and showed them. Now, in fact, they didn't go to the 98% level. They were like, no, we're okay. Just save us 75%. I'm like, fine, we'll do that for you. But regardless, it really is this easy to drop it in and see that. And then finally, securing customer data. Again, nothing will make your lawyers more nervous than hearing how people are moving data around today. The likelihood that just about everyone on this call is doing something that is borderline bad is pretty high. And it's not because you're not diligent, and it's not because you're not working hard. For example, here's a little data point that I ran into in the real world. Do you know in Europe, it's actually illegal or it violates GDPR to move an IP address? Like just a raw IP address is a violation because the last octet is identified in GDPR as personally identifiable information. So if you move IP addresses, which of course everyone is going to, you're actually supposed to drop the last octet. You're supposed to make it a 0 or whatever, make it some arbitrary number, and then call it a day. I can tell you with some authority that lots and lots and lots of people are grabbing their logs off Nginx or whatever it might be and shipping it to their data center in some country that's one country over, and then, we didn't think it was wrong. Guess what? You're in violation. I'm not a lawyer, by the way. Go check with your own legal counsel. But our understanding is that from many customers that is a problem. So you say this, you're like, okay, well, I'm going to separate everything, right? What if I have separate tables, or what if I have, separate entire databases hosted locally, plus I have separate ETL pipelines? That still generally puts yourself at risk, because the moment you left this bucket over here, you are in for bad time, because this is where you begin to start your regulatory risk. And I like to joke, you're like, okay, well, there's a playbook, and you know, we followed everything in the playbook, but you know, of course, the iceberg is below the line, and this is just a small list of the things that you can run into from your SOC and other regulatory compliance issues. Our proposal is instead you run your schema, your enforcement at the point of collection, either on the machines themselves or very nearby. Again, that doesn't mean you change your pipelines. It doesn't mean you change your databases. It just means the data is been moved and you get an audit log trail the moment you move it. We attach a tag to every single transformation that you can use all the way down the line and hand to your auditor to say, look, this data was cleaned at this location at this time, and these are the exact steps we ran through. Again, that's what we intend to do. This is not a commercial. My goal is to really just educate everyone about this. Use us, don't use us. I promise this, these problems are almost universal. And these are things where we really, I recommend, I don't care if you're using whatever Perl and SED in order to do this, please go think about how you're doing these things and so on. If you use us, great. I would love that. But I promise, if you just want to chat about this and have ways to make it better, I'm happy to do so. Like I said, with us, you're able to achieve all these things quite quickly and get audit logging for free. I think that's extremely important and something, again, that I think a lot of people are missing. How many times have you faced a data pipeline where you got to the end and you're like, wait a second, what time zone is this timestamp in? Or was this already converted from euros to dollars or whatever, right? It happens all the time and nobody remembers these transformations when you get to the end. Having a system that knows how to do that first class is extremely important. I'm almost out of time. Again, we can do the exact same thing around machine learning as well. So, everywhere you saw us running those transformation agents, you could run a full model. We just launched alpha for our model execution on the edge against your log data before you move it. Some really exciting things coming down that line. But again, the idea is put you back in control, let you execute models, even if they're lightweight models, where you're collecting the data, and generally you're going to see a big win across the board. This was another calculation we came up for a customer where we were going to be able to save them about 87% off their model costs. This was assuming 100 cameras per location, per building in this case, with 10 different locations. We show them a very clear way to save a bunch of money. So in summary, if you walk away with nothing else, shift left. Make your agents smarter by fixing your data. Process before you centralize. Use the compute. You already paid for the compute. You might as well use it to do log processing, to run your agents, to do so on and so forth. And at the end of the day, your agents, whether or not they are remote, whether or not they're centralized, whether or not they're sitting on top of a massive data warehouse, will only be as smart as their inputs, which includes all of that big data lake data that you're collecting right